Hi, so we're going to start talking about the binary search tree implementation. We'll start off talking about the node implementation. So as we've seen a few binary trees already, we can see that they are built from nodes. And each node, it should be obvious that they have at least three attributes. The first is the data, what's being stored in that node. Just one thing to know is that we typically don't actually make a copy of the data and store inside the node. Rather, the data in the node is the reference to the actual object that stored that is the actual data. And the reason for that is, but usually, data structures like this, it provides a way to access the data, but it's not a storage for the data. So usually these are just references. And then inside each of the node, there should be a reference to the left subtree or the root node of the left subtree, and also a reference to the root node of the right subtree, and they call left child and right child, as you would expect. Okay, so I've already typed this out. Here, there shouldn't be any surprise here. One thing I want to point out is we're calling this binary tree node rather than binary search tree node, because the node themselves, they don't they do not decide if the order of the left child and right child, right? It's just basically two child. The ordering, that's up to whether it's a binary tree or binary search tree. Okay. And then the next thing, the next thing I want to point out is, there are only three pieces of data. It seems to be a very simple class. So you may or may not choose to use the Pythonic property and setter decorators. I choose to do that for a number of reasons, and actually one of them is it actually allowed the subclass or class that inherits from binary tree node to be able to override these setters if they have to. And as a matter of fact, depending on how you do the assignment this week, you might need to do this. And so that's why I choose to use the Pythonic setter and getter, even for simple data attributes in this node. All right, and finally, I just want to point out that the way that I wrote the dunder string method, dunder string for no is just the data itself, right? Most of the time, we just want to know what's in that node. Now, for the repre, which I assume you know, but just a quick review, repre is kind of like the dunder string, but for programmers. So we might want to print out more information to help us debugging. And for that, I print out the data, I print out the ID of the left child, and I print out the ID of the right child. So in case I have to debug the node.